Hey guys, Dibbojyoti here from The Fast Engineer. On July 25, 2000, around 4:42 p.m. local time, Air France flight 4590 prepares for takeoff in Paris. The destination is New York. But this is not a typical passenger flight. This is Concorde, a supersonic aircraft capable of flying at more than twice the speed of sound. A normal passenger flight from Paris to New York takes around 7 to 8 hours, but Concorde could complete the same journey in just about 3.5 hours, less than half the time. But the speed came at a cost. Tickets were extremely expensive. A round trip from Paris to New York and back on the Concorde cost around $12,000. Only wealthy passengers could afford to fly on Concorde. It was not just a flight, it was a luxury experience. At around 4:42 p.m. local time, the aircraft begins its takeoff roll. The engines roar and the plane accelerates rapidly down the runway. Everything appears normal, but within seconds, something goes wrong. As the aircraft accelerates, flames erupt beneath the wing. Air traffic controller sees the fire and immediately alerts the pilots. The message reaches the cockpit, but by then they know the aircraft has already passed the point of no return. The Concorde lifts into the air, but it struggles to gain altitude. Engine performance drops. The pilots try to regain control, but the situation continues to worsen. The fire rapidly intensifies, flames engulf sections of the wing, and the aircraft begins to lose control. People on nearby highways watch in shock. Moments later, the aircraft crashes into a hotel near the airport. All 100 passengers and 9 crew members on board lose their lives, along with 4 people on the ground. A total of 113 lives lost. The world is left stunned. How could one of the most advanced and prestigious aircraft ever built fail like this? This was the first and only fatal crash involving Concorde, and it would change the future of supersonic travel forever. In the days that followed, investigators began searching for answers. But before we look at what they found, we need to understand the engineering behind this aircraft. Because this was not just an aircraft, it was one of the most ambitious engineering projects ever built. The goal was simple but extremely difficult: to carry passengers faster than the speed of sound, at over twice the speed of a normal passenger jet. Concorde could cross the Atlantic in nearly half the usual time. To fly at twice the speed of sound, you can't just build a plane. You have to reinvent physics. Let's look at these 3 parts that made the impossible possible. First, the droop nose. At supersonic speeds, you need a long pointed needle to pierce the air. But because of its long and pointed shape, pilots couldn't see clearly the runway during takeoff and landing. So engineers created a movable nose. As the engineering notes say, it was designed to be lowered during takeoff and landing to improve the pilot's view of the ground below. It's simple mechanical solution to a very human problem. Next, the ogival delta wing. Its shape was unlike any other commercial aircraft. This long curved wing was designed to remain stable at supersonic speeds, while also generating enough lift during takeoff and landing. At high speed, air behaves very differently, and this ogival design allowed Concorde to handle those extreme conditions with ease. Finally, the Olympus engines. Powering the aircraft were 4 Rolls-Royce Snigma Olympus 593 turbojets, derived from military technology, capable of pushing the aircraft beyond the speed of sound. But at supersonic speed, even the air entering the engine becomes a challenge. So Concorde used a special intake system to slow down and control the airflow before it reached the engines. Without this, the engines simply would not work properly. But there's one more challenge: heat. When an aircraft moves faster than sound, the air around it heats up rapidly, exposing the surface to intense thermal stress. To survive, Concorde was built using specially engineered aluminum alloys. These materials were strong enough to withstand high temperatures, yet light enough to keep the aircraft fast and efficient. The aircraft also used advanced control systems for its time to help pilots manage speed and stability. It operated with a 3-person cockpit system. A captain who was the pilot in command, a first officer, and a flight engineer, due to its extreme complexity. Even the fuel inside the aircraft was used as a tool. It was carefully moved between tanks to maintain balance during different phases of flight. This made it a highly complex system where aerodynamics, engineering, and human control worked together. It wasn't just a plane, it was a perfectly balanced machine. Now, let's come back to what investigators discovered. The failure did not begin in the air. It began on the runway. As the aircraft accelerated, everything appeared normal. The engines were at full power, speed was increasing rapidly, but hidden on the runway was a small metal strip made of titanium alloy, left behind by the previous aircraft, Continental Airlines DC-10. At high speed, one of Concorde's tires struck it, and in that instant, everything changes. This was not a single failure, it was a chain reaction. The tire bursts under extreme stress. Rubber fragments are thrown upward at high velocity. These fragments strike the fuel tank inside the wing. The tank structure is damaged. Fuel begins leaking rapidly. The fuel ignites near hot engine components. Within seconds, a small mechanical issue becomes a full system failure. As the aircraft climbs, engine performance drops. Systems begin failing one by one. Moments later, the Air France flight 4590 crashes near a hotel outside Paris. As we already discussed, the supersonic dream comes to a sudden end, but it exposed deeper engineering limitations. The aircraft was optimized for speed, not damage resistance. Its fuel tanks lacked full protection against high energy impacts. In engineering terms, the system had low fault tolerance. A single small failure led to a catastrophic chain of events. Even before the crash, Concorde faced serious limitations. Flying faster than sound creates a sonic boom, a powerful shockwave that travels through the air and reaches the ground as a loud explosion-like sound. For passengers, it was impressive, but for people on the ground, it was disturbing. Noise complaints increased, and over time, many countries restricted supersonic flight over land. Because of this, Concorde was forced to fly at full speed only over oceans, limiting its routes and flexibility. At the same time, it was extremely expensive to operate. Ticket prices were very high, so it was mostly used by wealthy passengers and business elites. Fuel consumption was also significantly higher than normal aircraft. And as environmental concerns started growing, this became a serious problem. So even before the crash, Concorde was already facing economic, environmental, and operational challenges. And after the 2000 crash, along with the global drop in air travel following the September 11 attacks, these problems became impossible to ignore. Air travel demand dropped worldwide, and premium services like Concorde were hit the hardest. And eventually, this led to the discontinuation of one of the most iconic aircraft in history. In 2003, both Air France and British Airways announced the retirement of Concorde. The Concorde took to the skies one final time on October 24, 2003, bringing an extraordinary chapter in aviation to a close. For years, it had symbolized the future, a future of speed, innovation, and human ambition. But now, the future had come to an end. But the story did not end with Concorde. Today, engineers are trying again. One of the companies leading this effort is Boom Supersonic, a modern aerospace startup working to build a new generation of supersonic passenger aircraft. Led by founder Blex Cole, one aircraft called Rupture, which the company says is being designed to improve efficiency, reduce noise, and help bring commercial supersonic travel back in the future, with plans targeting passenger operations around 2029. The Concorde proved one thing, that humans can break the speed of sound, but it also taught a deeper lesson, that engineering is not just about speed, but balance. Today, new technologies are trying again, and maybe one day supersonic travel will return. Not just as a symbol of luxury, but as a quieter, more efficient, and potentially more sustainable way of connecting the world.